All right, so we're working on worksheet 58. It is an accuracy worksheet, so we're going to get started on it and let you finish it up. I want to give you a reminder that we're using the top part of our sheet, and we have right triangles, and we're using the SOA-CATOA. Let me squeeze in here and focus this real quick. So in SOA-CATOA, I have to have a right triangle, and then what you name the sides depends on what angle we're focusing on. So we are looking at a right triangle. If this is the angle I'm focusing on, the side along it is adjacent, and the side that's not touching it is opposite. So you can see this angle opens up, and this is the opposite side. And then across from the 90-degree angles is always your hypotenuse. So we always know the hypotenuse, adjacent side, opposite side. If I change the angle to this one, then that makes this the adjacent side. And if this is my angle, this is the opposite side. So we have our SOA-CATOA that helps us. We've got sine, which stands for, the SOA stands for sine of theta is opposite over hypotenuse. There's your O and H. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we don't need to memorize those. We can use our sheet. So let's go ahead and look at these. We're starting off, and it just says state if each triangle is a right triangle. So we're starting off actually with the Pythagorean theorem. So to prove it's a right triangle, we're going to show that a squared plus b squared equals c squared. So that's taking us back to proving it. So if I look at this, how do I know which ones I should use for A, B, and C? Well, C is always the longest side, so that's going to be C. We'll call this A and B. So I'm not trying to find any angles. I'm trying to prove it's right triangle. In order to do that, Pythagorean theorem. So 35 squared plus 48 squared should equal 60 squared. And I would definitely be using my calculator on this. I want to try to do this by hand, so I need my calculator. And we would take 35 squared plus 48 squared. I'm just going to toss it in here. I get 3529. All right, so let's see what 60 squared equals, which I know is not. It's 3600. So these are not the same. Close, but not the same. So that means it is not a right triangle. All right, there you go. So same idea on number 2. This one is not a right triangle, so it would not be a Pythagorean triple. This one may be a right triangle, but it could not be a Pythagorean triple because they're not whole number sides. All right, if you look at the next one, it says find the missing side of each triangle. Well, guys, I think I'm going to make my life easier and just use Pythagorean theorem here. Round your answers to the nearest tenth. So again, you need to pay attention to what you're looking at. Here you have the two legs A and B, and this side is C. And over here, you have your A, your B, and this is C. So again, we're going to use Pythagorean theorem to find the missing side. I could not use sine, cosine, or tangent because it would take me a little bit of effort to find this. I would have to find an angle, which I could find this angle here by using opposite and hypotenuse, but that doesn't help me find the missing side. I'd have to play with the angles and work backwards, and that's what we're going to get into next. So I'm just sticking with Pythagorean theorem. I know two sides. I'm going to use what I know. So I'm going to say a squared, or in our case x squared, plus 10.4 squared equals 14.2 squared. Again, if you want to make that x, you can. So I'm going to do the math here. A squared plus, I'm going to use my calculator to help me out. That's 108.16. And equals 201.64. Now, in order to solve this one, I'm going to have to subtract that 108. So that's definitely why I'm happy to use a calculator. So I get a squared equals, take away that 108.16, 93.48. Now, in order to find the actual length of the side, I'm going to take the square root to cancel. And I'm just using my calculator. Instead of retyping it, I am typing in the square root and I'm hitting second with the negative sign to type the square root of that answer. And it's 9.6685, and it said nearest tenth, so 9.7. And what would my label be? Should be in inches. All right, so pay attention to what sides you have for your Pythagorean theorem. Okay, now we're going to get into using sine, cosine, and tangent. So the beginning was just a review of Pythagorean theorem. And then down here, you can see, again, I have right triangles. And in both of these, I actually know all three sides. So they want me to find the tangent of x. So what I asked you guys to do before was circle x. So I'm just finding the ratio. I'm not finding the angle. I'm not finding a side. Just want the ratio reduced. So I'm circling this. That means that the 16 is adjacent, and the 12 is opposite, and the 20 is the hypotenuse. We shouldn't be guessing which side is which. Whatever side is along the angle is the adjacent. Hypotenuse is always locked in there. Okay, now that I know that, my sheet tells me that the tangent is opposite over adjacent. So the tangent of x is the opposite 12 over adjacent 16. Okay, don't leave that. You need to reduce it. So I'm going to put my final answer up here. Guys, a lot of people, I was working on this. In my calculator, I type in 12 fraction 16, and I just hit enter, and it reduces it for me. I don't have to do any extra work, okay? That doesn't happen in all of your calculators. In some of your calculators, you're going to type in 12. You have a fraction symbol. It looks a little different, has a slash. 16, and you have to hit the simplify key that's right here and hit enter. And then you have to simplify it again. It doesn't always reduce the whole way. So make sure you simplify it enough. Now, if you're ever simplifying and you have a mixed number, so let's say it was flip-flopped. Let's say it was 16 over 12, and I hit simplify, or I hit enter to reduce it. See how I get that mixed number? Go to your second function, and then there's a key that's mixed number to improper, and that's going to give me back the improper reduced fraction. But again, if you have that light blue calculator, you're going to be hitting simplify first, get it down to the simplest mixed number, and then you can come back. All right, so this one reduced to 3/4, and that is my final answer. All right, now, same idea on these. So again, if they tell you find the sine of z, I want you to circle z, and I want you to label it. Here's my adjacent, here's my opposite, here is my hypotenuse. And then you're going to find and reduce that fraction. All right, next one. It says, same thing. It doesn't give you the hint. It says, find the value of each trig ratio. Hint, you may have to use Pythagorean theorem. Well, all three sides are given, so you guys lucked out. You don't have to use Pythagorean theorem on these. However, if I was missing this side and they said find the sine of c, well, sine is, let's say I was missing this. This is my adjacent. This is my opposite and hypotenuse. If I was missing this, I would have to use Pythagorean theorem to find the missing piece, and then I could use my function. You guys lucked out that that is there. So these problems are no different than what I just went over.